Here we have the review of section 8.2 and 8.4, getting ready for the test here. Find the volume of the solid when y equals 1 over x to the third in the first quadrant starting x equals 1 is revolved around the y-axis. Let's get a different color here. This is 1 over x to the third right here. That's what the shape of it looks like. And if we go half turn around the y-axis, there's the other side. Now we're going to use the shell method to find the volume. So there's one shell, there's one cylinder right there. And the area of a shell of a cylinder, of the lateral surface area of a cylinder, is 2 pi RH. So if you pick an x right there, there's the radius from the middle off to the side. There's the radius, and that's the x. And then if you pick the x, if you have that x value, to find the height, you plug that into the function. You plug it into 1 over x to the third. So there's the height. So we have 2 pi RH, and we're integrating from 1 to infinity because it's in the first quadrant. So it's all of this area rotated around the y-axis. Well, we have the limit as a approaches infinity, 1 to a. That's going to cancel out to 1 over x squared. So you have x to the negative 2. And then we add 1. So you have x to the negative 2, add 1. That's x to the negative 1, and then times negative 1. There's the integral. Plug in the a, plug in the infinity. That piece goes to 0. Plug in the 1, and you get 2 pi. Let's uncover the rest of it here. Evaluate this one. Well, we have, can't do tabular because I really don't know what the integral of that is. So we have u substitution. We're going to let u equal x to the third. Here is, no, excuse me, not x to the third. That's not correct. U is equal to negative x to the fourth. So we let u equal that. Derivative is negative 4x to the third, but we don't have a negative 4x to the third. We just have an x to the third. So we're going to divide that negative 4 over. There it is. And then, yeah, so here's the substitution part. The x to the third dx becomes negative 1/4 du. E to the negative x to the fourth becomes e to the u. Integrate. Plug u back in. That's negative x to the fourth. Now plug in infinity. Now that 1 over 4e to the x to the fourth, that negative power goes down to the denominator. There's plugging in infinity, there's plugging in 1, and the answer ends up being 1 over 4e. This one is 0 to the 0, so we have the limit of natural log of f of x. We want to take the natural log because that brings down the power. Now, I didn't bring down the entire power, I only brought down x squared, so it's kind of your choice. In this case, you could bring the whole thing down and you could end up with the same answer, but I thought this would balance it out a little bit, and then the derivative should be a little easier. Well, we make the fraction, 1 over x squared. We can use L'Hopital's because we've decided it's an indeterminate form. So the derivative is, that's the 1 over x to the fourth, that's what I have right there, times the derivative of the inside, which is 4x to the third. Now the derivative of 1 over x squared, that's x to the negative 2. So negative 2x to the negative 3. So negative 2 over x to the third, that's the derivative of the bottom. And there we have that. Well, this cancels out with 3 of those. That leaves 4 over x. And then we could just multiply by the reciprocal instead of dividing. So there's multiplying by the reciprocal. 1 cancels out there, leaving 2. So we end up with negative 2x. That's 0. E to the 0 is 1. Evaluate or state it diverges. So we have 4 to infinity. So there's limit as a approaches infinity. And this is a u substitution. So we're going to let u equal x squared minus 4. The derivative is 2x dx. We don't have a 2x dx. We just have an x dx. So divide by 2. There's 1/2. Now, the integral part, 1/2 du replaces the x dx. And then we end up with 1 over the fourth root of u. Well, that's u to the negative 1/4. So when we add 1 to this, that's u to the 3/4 and then times 4/3. But we still have that half kind of tagging along right there. The antiderivative ends up being 2/3. Here it is right here, 2/3. We plug the u back in, x squared minus 4 to the 3/4. We plug a in, plug infinity for that. So this is the piece that causes the integral to diverge because that'll go to infinity. This one we know, if we go limit as x approaches infinity of this, that's really e to the x if we didn't have the 2, so that ends up being e squared. Evaluate. Limit as x approaches 4 of this. Well, if you plug 4 in the top, integrating from 4 to 4 is 0, and 4 minus 4 is certainly 0, so there's your indeterminate form. We use L'Hopital's limit as x approaches 4. The derivative of the top, the derivative of the integral is x squared. And then the derivative of the bottom is 1. So it ends up being x squared. We plug 4 in there, and you end up with 16. Use rates of change to evaluate each. You can certainly use L'Hopital's. I have a little mistake here. This is not 0. This ends up being infinity. Oh, I didn't get the pin to work. Let's try that again. There we go. Infinity. But we have this goes to infinity. I say little infinity, but I guess what I really mean is it goes very slowly to infinity. This one, comparatively speaking, goes very fast to infinity. So when that happens, the denominator is outpacing the numerator, and this ends up to be 0. Now the opposite is true here because we turned it upside down. Now when the numerator goes to infinity quicker, then your fraction is headed off to infinity. Let f of x equal x squared. Estimate this integral by using a right-Riemann sum with 4 equal subdivisions. Well, we're integrating x squared, so let me draw roughly. X squared, and then that's going to be a half. That's a half 1, 3 halves, and then 2. So here's the rectangles, and the bases should be perfectly 1/2. These are a little off. But now we're plugging in a half, 1, 3 halves, and 2 for the right side, for a right Riemann sum. And we're plugging that into x squared. So we're squaring each of those, right? So there they are squared. All that adds up to 30. So we end up with 15/4 on that for a right Riemann sum. Evaluate or state it diverges. Here the power in the denominator is 1/3. That's less than 1. This is going to diverge. Because when you have x to the negative 1/3 and you add 1, that's x to the 2/3. So the variable was in the denominator. Well, now it moved up to the numerator. And of course, that's times 3 halves. But now when you plug infinity into a variable that ends up in the numerator, that's headed off to infinity. This one over here to the right, the power is 1. That's going to diverge also because the antiderivative now is natural log of the absolute value of x. You plug infinity into that, you're headed off to infinity. This power is 3. So the power is 3, which is greater than 1. Now this is going to converge. Now it converges because we have x to the negative 3. That's the same thing. When you add 1, you don't get that positive power. You still have a negative power. So there's the antiderivative for this one. Antiderivative, that goes to the denominator. We plug infinity in. This piece becomes 0. And then we have 1/2. So the answer on this one is 1/2. Evaluate or state it diverges. We're going to do the limit because we have an improper integral. We're going to let u equal the square root of x, and the derivative of square root of x is 1/2 x to the negative 1/2. Well, that gets square root in the denominator. Well, I don't have 1/2 square root of x. I have just 1 over square root of x. Multiply the 2 over, and we get this statement here. Now, 1 over square root of x dx becomes 2 du. Well, we still have this piece to deal with right here. We're dealing with that. We got rid of the 1 over x square root of x. That's done. We've substituted that. Well, if we square both sides, u squared is equal to x. Just by squaring both sides on this, we get that statement. So now instead of having x here, we can have u squared. So we get 1 over 1 plus u squared. Now that's inverse tangent. So the antiderivative is actually sitting right here, inverse tangent. We're going to plug a in. Now it's inverse tangent of u, and remember u was square root of x. We plug a in, plug infinity in for that. This right here, remember the graph of inverse tangent. Let's take a look at that real quick. Here's pi over 2, and down here is negative pi over 2. And inverse tangent looks like that. So as x approaches infinity, inverse tangent is leveling out to pi over 2. That's why this piece becomes pi over 2, and then the 2 just kind of tags along. So the answer ends up being pi. Use a calculator to find the average velocity from 0 to 2 if the position function is t squared minus 1. So it's s of 2 minus s of 0 over 2 minus 0. It ends up being the slope. So this is how far you went, and this is how long it took. So it ends up being 2. Use a calculator to find the average velocity from 0 to 2 if they're giving you the velocity function. Well, you're finding the average of the velocity, and they give you the velocity function. So the way you find the average velocity here is a little different. We use integral. So that's really 1 over 2 minus 0. So 1/2 0 to 2 of the velocity function, plug it into your calculator, ends up being 1/3. Now, we could certainly do this by hand, but in class, I used a calculator, just kind of speed it up. Use the calculator to find the average acceleration from 0 to 2 if the velocity is t squared minus 1. Well, we're finding average acceleration, so now that's slope. That is v2 minus v0 over 2 minus 0. That ends up being 2. Use the calculator to find the average acceleration if s of t is equal to t squared minus 1. And this answer is actually not correct. Let's get the velocity. V of t is 2t, and now we want v of 2 minus v of 0 over 2 minus 0 to find the average acceleration. Now that's equal to, let's see, if I plug 2 into this, we get 4 minus 0 over 2 minus 0. That's going to be an answer of 2. But think of it this way also. If you take the derivative of velocity, you just get 2. Well, if the acceleration is always 2, then the average is certainly going to be 2, no matter if we're going from 0 to 2 or 0 to 100. Use the calculator to find the volume if y equals 2 plus e to the negative x is revolved around the x-axis from x equals 1 to 3. Well, here we have, let's see, we start out with, I know what e to the x looks like. And here's e to the x. Well, e to the negative x looks like this, but now this has been pushed up to, so instead of intersecting at 1 here, the y-intercept instead of 1 is up here at 3, and then this is leveling out to 2. Well, we're integrating from 1 to 3, but we're doing the volume from 1 to 3. So 1 to 3 is probably about right here, 1 to 3, and we're rotating this around the x-axis like that. So the radius goes from the x-axis to the curve. So the area of a circle is pi r squared, but our radius is the function value. There's radius squared, pi r squared. And when you plug this into a calculator, you get 29.338. A particle moves along a straight line with a position function. Excuse me, that's not position. That's a mistake. This is, no, that is position. I had velocity. Oh, no, velocity. With the velocity function. V of t equals negative t squared plus 3t minus 2. Find the total distance traveled from 0 to 5. Now, if we didn't have the absolute value here, that would be displacement. But if you want the total distance traveled, you need to find the absolute value of the function and then take the integral of that. So 14.499. Give each indeterminate form. This one is 1 over infinity to infinity, but 1 over infinity is 0. So this is 0 to infinity. This one, if you plug infinity into this piece right here, this becomes 0, and we have 1 raised to the infinity. It doesn't really matter that it's 5 times infinity. That's just infinity. Natural log of x goes to infinity, x squared goes to infinity, infinity minus infinity.